Starting with page 8, the sample problems, here we go. Find the cardinality, that means the number of terms. How many terms are in there from 0 to 3,000? How many terms are from 1 to 3,000? 3,000. Notice if you take 3,000 minus 1, it's 2,999. So, if 1 to 3,000 has 3,000 terms, how many terms is it 0 to 3,000? X is a vowel in the alphabet. How many vowels are there? A, E, I, O, U. I was going to choke the first person that says count Y as a vowel.
That was a question. You know my parents said that?
Strike that. I will not choke anybody. Forgot I was recording myself. Five. Y is not a vowel. But that was good input. Very, very nice. A is the set of current U.S. senators. Oh boy, got to go back to your APS days. How many U.S. senators are there? Identify as finite. You can count the number of terms, or infinite. You cannot count all the way up to infinity. So, part A. You can count them. There are 3. Part B, can you count those? Anytime it dots and doesn't finish like this one finished, dot to eternity, that is infinite. So far so good? State whether the pairs are equal. Equal means they have the same exact contents. So, doesn't matter the order. A, it's in there. B, it's in there. D, it's in there. I forgot C, it's in there. Are these equal? Yes. 2, 4, 6, X, such that X is even. 2, 4, and 6 are all even. Are these equal sets? No, because any even number would work, and this would be an infinite set. They are not equal. K, car, equal 3, 7, 12, 14, 3, 7, 12, 14, 0, not equal. Remember, if we had something like K car, R, would those be equal? Yes, because R, sounds like I'm a pirate, doesn't it? R, it only has to occur once. Fill in the blank with subset or not a subset to make it true. Is ABC a subset of ACB? Are all the elements of this also elements of this? Anyone? People from at home? Johnny's saying yes. Are all the elements of the first set also elements of the second one? No.
Yes, it is.
What? Yes? Because what?
Oh!
Oh, he just says they're reflected across the y-axis. So he thinks, how about, can any set be a subset of itself? Sure can. Anybody have any questions so far? Determine whether each is a subset or not. M, W, F. Does this contain M, W, and F? Shucks, doesn't have the F, not a subset. A and D, got it all. Is the empty set a subset of itself? Yes. 2, 1/3, 5/9, is it a subset of the set of rational numbers? Yes. anything that can be written as a fraction is a rational number. All right. Oh my goodness gracious. Last page. Here we go. Decide whether proper subset, remember with no bar, that's proper subset, or both, or neither, could be placed in the blank to make it true. A, B, C, A, B, C, not only is it a subset, it is proper, so both. 1, 2, 3, 4, 1, 2, 3, 4. It's a subset of itself, but is it a proper subset of itself? Just subset. And then there's a strange true-false question that Johnny ran into, where it says, list the item that's true. We want to pick the most specific true fact about it, okay? Because there's crazy, but 2 correct answers to Johnny's question, so he had to pick the most specific correct answer. Proper subset, regular subset, both, or neither. Red, blue, yellow, red, blue, yellow. It's the same. It's equal. So, it can't be a proper subset. It's just a subset. Sunday, I assume. Monday, Tuesday, not a subset. This one doesn't have Tuesday. 5/9, that one doesn't have 5/9. So far, so good? Tell whether the statement's true or false. This time they give you the universal set as the letters A through G. And then they give you some of these others. Is C a proper subset of U? B, F, G. I think that's a movie title, right? B, F, G. Yeah. The Big Friendly Giant. Is it a proper subset of U? Yes. B, is it a regular subset of C? Are all the elements of B also elements of C? No. You have to do these in the right order. That's the only thing that's going to trip you up. D, is it a regular subset of B? So, is D in B? No. False. Is the empty set a subset of D? We look up at D? Yes. Do I even have to look up at D? Not really, because the empty set's going to be a subset of any set, including itself. So, this is true. I don't even have to look at it. D is not a proper subset of B. That is true because B does not contain D. I hate those double negatives. So far, so good. Does anybody have any questions on any of those? And given the definitions of A and B from up above, fill in the blank. A blank B. A and E, A and E. So we want to fill in the blank with the most specific symbol that we can think of. What's the most specific thing that you can think of? What do you think, Alyssa? Guess one of these. A, it is indeed a proper subset of it. Good job. Yep, because it's a subset and it's not the original, so it's a proper subset, and that's as specific as we can go. Find the number of subsets. If the set contains 1, 2, 3, 4, 5 terms, remember, if one of these letters would repeat, you don't count it a second time. So we've got 5 terms in the list. The number of subsets is 2 to the nth power, or 2 to the 5th power, or 32. subsets. Now, how many proper subsets are there? One less than that. Proper subsets. Are we done? Oh my God. Find the number of subsets and proper subsets of each. 2 to the 4th and 2 to the 4th minus 1. I'll just set them up so that we can crank these things out. The days of the week. How many days of the week are there? 2 to the 7th. And proper subsets, 2 to the 7th minus 1. The set of all x is such that x is an odd whole number less than 4. An odd whole number, so 3 and 1. 0 is neither odd nor even, but we would consider it even for finite math. So this set contains 2 elements. How many subsets and how many proper subsets? 2 to the 2nd and 2 to the 2nd minus 1. True or false? There are exactly 31 subsets of B. I don't even have to look at B. 31 is not a power of 2, right? There might be 31 proper subsets, but there's no, subsets have to be powers of 2. So, false. There are exactly 4 subsets of D. 2 to the 2nd is 4, true. There are exactly 127 proper subsets of U. 1, 2, 3, 4, 5, 6, 7. None of those letters repeat. 2 to the 7th minus 1. How about this, guys? 2 to the 7th minus 1. Is that what we're looking for? 2 to the 7th. Hit it. Minus 1. 127, 127. True. Last problem. Here we go. U is the digits 1 through 10. Remember, the number of values in here is 10, but when you subtract the biggest one minus the smallest one, you get 9. So you can't just subtract them to get the number of terms. You got to subtract them and add 1. Find the complement. So if this was A, we want to find not A. What are the numbers in the universal set that aren't in A? So you just do it one at a time. Is 1 in A? Nope. It's in not A. Is 2 in A? Yes. 3? Nope. So it's in not A. Is 4 in A? Nope. So it's going to be in not A. 5, 6, 7, 8, 9, 10. Did I get them all, guys? Between A and not A, I should have all 10 of those numbers. Let's call this one Z. Then what would its complement name be? And this is a history lesson going back to World War II. Thank you very much. 1, is it in Z? Yes. 2, is it in Z? No, so it is in not Z. 3, check. 4, check. 5, check. 6, check. 7, 8, 9, and 1 again. So 2 is the only value in not C. 10? 10. Thank you, Johnny. 10. 10 No, so it has to be in not Z. 10 has to be in not Z. I forgot to check 10. Okay, how do I shut this thing off?